Monday. Okay, so next Monday is spring break. And then week after that is your midterm exam. So next Monday evening at 7 o'clock, we will have the midterm review over Zoom. You guys receive already, did I send to you email or announcement? There is the invitation, Zoom invitation, so you can join me. Let me check your attendance first. Nicholas, thank you. Aaron, Winston, Yandel, Brianna, Zuli, Remy, Yosef, Carla, thank you. Abdul. So today we do not have not many attendance because of the weather. Weather is not really pleasant. Sure, you can share. Send it over there. So I wanted to start your Raspberry Pi. Julie, did you? Okay, good. Very good. The other side. Yeah, yeah. I guess I need I better use one side. Then you can use the other side also. Okay. Okay. The security is very, very important, right? One of the major reasons why everyone wants to have Linux up and running if they want to make their production systems seriously is because of the security management. Linux is very secured. So we'll do today some of the security commands. Linux has evolved into one of the most popular and versatile operating systems. Many features mean a broad attack surface can create highly secure Linux systems. So we're going to look at discretionary access control. And also while we understand mandatory access control. And typical vulnerabilities and exploit in Linux, best practice for mitigating any security threats, new improvement for that. This slide gives you the broader picture of the security management in most cases, not only on the operating systems, but whenever you say about the security management, this paradigm can fit. So usually it is an object that you want to keep secure, right? It could be file, in our Linux operating systems, a directory as a whole. And, and also there is a subject who wants to access these objects. Could be user. So user can access it manually, right, usually. But there is some process, some other program, not you manually, but you can run some program. So let program intrude your system, attack any infrastructure on behalf of you. That could be possible too. This is very dangerous, right? Those who do not know the system well, but know how to run the process, if that process is acquired by someone who may not know much, naive user may enact something. So the effect from that the process running may be may lead to severe the damages that may happen, right? So before you use any process, you have to understand the process. And also we know action, right? Basically in operating systems, when you see the actions, then read, write, and execute, right? Read, write, executes. Depending upon the applications or systems that you are using, there could be more actions available. For example, if you're thinking of banking systems, then it's not only read, write. Read is something that you want to see your balance. Write, you want to put the deposit on your accounts. There may be some other things as transfer, right? You want to transfer some of the money from your accounts to your friends. Or sometimes a banker wants to calculate some of the interest if it is applied regularly. Some of the audit process may be required. So all different kinds of actions are available. So basically, if we are thinking of operating systems, so then read, write, and execute. Execute could be much, depending upon the program that you want to, which program you want to execute. Some programs may affect severely, some programs locally. So to make the transactions between subject and object through actions securely, then we need to think of object permissions, right? Whether we want to permit or deny, that decision needs to be made. So, and also all of these can be controlled by kernel. Kernel is a core portion of your operating systems. Sometimes you may need to check the kernels to do some of the action determinations. So first we need to think of discretionary access control, so-called DAC, as opposed to mandatory, then there is MAC. Okay. As I said, we're going to work on DAC rather than mandatory. Mandatory looks like more powerful, right? So it is a system-wide security policy. It is already given. It is already based on this kernel deep inside of your systems. So we don't do much about this. Okay, not the system-wide security policies. There are many versions of Mac available. By the way, the Debian operating systems has this AppArmor. Therefore, our Raspberry Pi also has an AppArmor. But a little bit, we don't, as I said, we don't go deeper there. So we may check why we don't go deeper later. So with that in mind, so we will do DAC, discretionary access control. So more like access, we want to see how we can control user access. So the owner of an objects could be file, another process could be another or process. See here, process, it could be a subject. Process, it could be also objects. Some process, whether you want to allow to be executed by, to what subjects, or sometimes you run a process to access some other objects. So process could be subject and objects. So usually we need to think of the permissions. Permit what? Permit actions, right? So action, as I said, it could be one of those three. Basically, there is a primitive type of actions: read, write, or executions. Read, write, or executions. Yandel, come in. Fill out this form. And this is yours.
What?
There's orange ones. I'm not sure that works. Okay. So read, write, and or actions. We want to permit on one of or some of those actions. We can do that permission based upon ownership. And also we call that ACL. That is access control languages. Enforced by kernel using UID and GID. So user ID or GID, group ID, and permission bits. Discretionary, because the owner can change permissions or administrator can change the permissions. Therefore, grant access. It's not by system. It's not deeper inside, but it is more application level of access controls. So we can practice some of those here. So I wanted to start your Raspberry Pi and bring one terminal. And change some of, so I want to make a mkdir, and today is 16th of March 26, like I did. So we had 9 March 26 and 16 March 26, so that is for today. So change into that directory. So CD 16, March 26. In there, nothing, right? If you want to see in the long list with the hidden files also, LA, therefore you can see the hidden files. Dot and dot dot. Dot is current, and dot dot means my parent. And there, I want to create one of the files. So simple way that you can create files is touch, right? Touch secrets.txt. So when I see that, then I may be able to see that in the long list, ls-l, then secret.txt created today, owned by me, owned by group. Group is myself also. This is a timestamp. This gives you the permission. I want you to see this carefully. The highlight that I made here. Do you see how many characters? Abdul, how many characters? The one that I highlighted. Can you count? Can you count? Winston? I think you have a clear view, right? How many characters? The highlighted area here. 4 characters? No, everything. Yeah, 4 appears. Even you can count a dash. Yeah, count dashes as well. 9, thank you. Here on this slide, permission is read, write, execute, right? RWX. So how many sets of RWX? If we have 9 characters allowed, 3 sets, right? RWX, RWX, RWX. It should be RWX, RWX, and RWX. But right now, instead of RW, X, instead of X, it put dash, right? And another sets, RWX here. See that highlighted, the RWX, R only appears, W and X dashed. And one before 3 of those, RW dash, and one after, R dash dash. So you may see clearly 3 sets, right? Three of those actions may be grouped. So 3 groups may be indicated there. So first 3 group, as I said here, we're thinking of the user, okay? I mean the subjects. Subject could be as a user or could be a group. As you may see here, user ID or group ID. Group is important in Linux operating systems because it is a server. If it is a server, then there may be many users available. So users may be grouped. So you may be included in one group or more groups, right? So now back here, Then first three indicates here how a user, there are three groups actually. So user, single user, that is a one group, and group, that is a group, and the rest, we call that others. So we say U for user, G for group, and O for others. So first three actions are granted to user. Who is user? Here, Jae-yoon. Next three actions, actually read the action only. Read the action is granted to the group. What is a group? Group is Jae-yoon again. So first name here is a user, and next name is a group. And then the last three actions are granted to anyone in the system. So you can divide the users inside the U. Let me bring them up, by the way, users. What users are available? So when I bring this, and if you can see the users from where? What file contains the user information? Anyone can remember that? Nicholas? What file could contain user information in Linux operating systems? You guys didn't go into that level when you look at file systems, file structures. If you see the file structures, for example, etc, the password, that's a password file. And if you want to see that password files, you can see it. Hi. Good morning. So there are some files that you may be able to see. Jae-yoon, there's a file, right? I mean, there's a user. And Mercy, another user. Probably I created this, right? Security, maybe another user. Engineer, another user. Alice, another user. CYCMD, another user. OTC ASU, another user. MySQL, that is another. This is not a user, this is a server. Okay, so you can see the way that you can see the user. If there is a home/home something, then that is a user, right? So maybe those guys are user, right? If you see their information, so 1000 and 1000 and 1003, 1003, those are the number for first number here, there is a user ID. Second number, there's a group ID. So you can see those also from groups. Is it group? Yeah, if you see the group, then Jae-yoon is in group number 1000. Mercy in group number 1003. That's what we looked at. I want to see, not groups, password, maybe tail minus tail minus 9. Okay. Then I can see Jae-yoon here, 1000 and 1000. 1000 is my user ID, and the other 1000, that is a group ID. So if you see in this file, group, it says Jae-yoon is in 1000. And Mercy is 1003. Mercy is 1003. You can see that on your Raspberry Pi as well. So I want you to find out yours. What is your user ID? Julie, what is your user ID on your Raspberry Pi? Brianna, can you see yours? What number? What is it? Your UID? So you cannot see yours? Huh? You haven't done yet at all? I want you to stay after class so that I can help you. Today I brought my monitor, keyboard, and mouse so that I may be able to help you, Brianna. But maybe after midterm exam, I may not bring these things because I already set up, and most of you guys are set up, right? So should I bring this every time? No, right? So if you didn't do it, but if you want to it in this class, therefore you can follow my lecture by practicing. Please do so. Okay, back to Zully. What is the user ID in your case? Do you see it? Tail slash, type this, tail -9 slash etc slash password in Linux, PASSWD. Do you see your name there? What is your name? What is your login that you created? Did you see your... What is your... What's the name that you created? Yeah. Your user ID is 1000. Second one is group ID, first one is user ID. So probably everyone has 1000 like me here, right? 1000 is automatically given when you first install your operating systems. So that is a name that you entered, right? So it should be there. What am I doing here? Okay, so back here, now we have a secrets.txt, which is I may be able to do read and write, right? Because I am Jae-yoon. I am here, so RW, read and write. What about the group? Right now, 1000. When I do here ID, then I can see here, what is my UID? 1000. What is my group ID? 1000. Group number? 1000. It's already, I know, right? So these are the identification associated with me. So I'm here, so I can do read and write. No execution. Why I cannot execute? Because this is not executable. This is simply a file. By the way, it has nothing, right? Size of that is 0. That is granted me. All others can, I mean, the group can read it. All others can read it, right? So if I change this to ch mode, for example. What is ch mode? There's a change mode. I can see that manual, change mode, then the change file mode bits. File mode bits. What is it? This is file mode bits. So I want to change this. I give 600 here. That is some of the code that I gave. We'll learn that a little later. And then I want to assign that, I want to change that mode to the file, specific file, secret.txt. After that, when I see that file permission bits, it is changed. Remember previously it says dash, rw dash, all dash dash, all dash dash. When I issue that command, it became rw dash 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 dash. That comes from this 600. This number tells us something. By the way, 600, if I give you quick, 600 means four means read, 2 means write, execute means 1. So we use only 3 numbers to combine. If I want to give read and write, I can add these 2. Then it'll be 0. If I don't give you anything at all, then it'll be 0. If I give you the permission, write and execute, I can add 2 and 1, so it'll be 3. If I can give you read and execute permission, then it'll be 5. By having 4 to 1, any combination of additions or none, I could have all numbers distinctively from 0 to 6, or actually 0 to 7. If I add all of those, then what? 7, right? 4 plus 2 plus 1, then that is 7. See here, all the numbers. 0, 1, 2, 3, 4, 5, 6, 7, distinctively. So you can manage those, all the grant of the privileges, by adding those numbers distinctively. So I said the 600 here, right? Remember where is it? I put here 600. 600 means, 6 means what? Read and write, right? Because read is 4, write is 2. I add them. Therefore, it'll be 6. So read and write. If I give 600, then the first digit here, third digit is indicating me, myself. Second digit indicates group. First digit indicates others. Look at these 3 digits, 600. Then the left digit, which is the third digit, this tells me myself, user. It says 6. 6 means read and write. Therefore, it can give read and write, no execute. So read, write, dash. And next one is 0, which means I don't give you any, 0. So all dash, dash, dash. And next one also 0, dash, dash, dash. So by looking at this, you can expect these files can be read and write by user only. No other can access it. Initially, when I touch the file, when I first created it, it gives me this. How come I have this by default? That we will know, okay? So a little bit of a math. It's not really math. A little bit of numberings, right? So we play with some number. It comes from, for example, UMask. What is a UMask right now? 0022. So I wanted to focus only first, second, and third digits. Fourth one later. So it says 022. 022. 022 is because it says mask, UMask. It sounds like by default, whenever file is created, I go through that mask, UMask. So I create this by touch, by default, go through UMask. I have this. How come you have this? By the way, I have a number here, 022. 022. Here's the magic. This is not really magic. This is our agreement. If it is a file, then you need to subtract this number from 666, 666. Subtract this number from 666. When you subtract this number from 666, what is it? 644, right? 644. So this guy has a 644, like I did here, 600. So the effect of this is for this change mode 644. 6, therefore, read and write. Myself read and write, 6, right? And then group, it says 4. 4 means read only. So we have R dash dash. Another 4, R dash dash. Let me rewrite here. So mask, UMask here. Zero, zero, 2, 2. If it is a file, so 4 files. We need to subtract that from 666. Only consider this is a special, so we'll look at this. 0, 2, 2. We subtract this, then it'll be 6, 4, 4. So by default, initially, all the files will have 644. If we set UMask 0021, you can set the mask. This UMask also, there's a default to UMask. There's a given that is originally set by this operating systems. But you can change it if you want. So 644 means this is a 6, this is a 4. Okay, so this is me, myself, user. This is a group. This is for all others. O, or sometimes we call this W, the world. Is it clear? It is very straightforward, but it takes a little time, right? You have to. I think this is the first time you heard some of the small numbers that can represent seven different situations. Remember the three those numbers, 1, 2, and 4. So we represent how many situations? 8. 0, 1, 2, 3, 4, 5, 6, 7. So if we want to represent 8 or smaller number of situations by using smaller numbers, then you can use 1, 2, and 4. I'll give you 1 minute to think. You have a question? No, I said that I want you to think. Chris, do you follow this so far? Yeah. Practice it, practice. Yandel, did you fill out the form? Bring it to me. You can open the box and see what you have. Good. You guys are cleared? See some relations, the change mode and the UMask. The mode that you can get from UMask, right? If it is a file, then you can subtract UMask from 666. If it is a directory, then you can do it from, you can subtract this UMask from 777. So either 777 or 666. So 777 is one of a lucky number, right? If you go to Campbell machines. You guys been there? Okay, if you understand that, then go back to our, okay. So we created it, change mode 600. That's okay. So this is one way that you can set the mode, access control. So basically how can you control access? How can you control user access? The simple way is by this command, chmod. And then there is another command, chown. Therefore, you can set user and group. User and group. Right now, the user ls-l secrets.txt. What is user and group? For this file, Jyun and Jyun, right? But since I have another user that I already created, as you guys see. There is called Alice. Okay, username Alice. Her UID is 1001. Group ID is 1001. Okay. And then this is home, and this is the shell. That is Alice. So let's see. I want to change this to, this is owner is Jaeyoon and this Jaeyoon also. So I want to change ch mode, no, ch own. If you want to see the manual, then you can do man CHOWN. Change file owner and group. This manual page is documents. ch own changes the user and group ownership of each given file. So for that given file, we want to change the ownership. So let's try that. CHOWN, that is a command. And now if I want to give Alice as a user and the group, let's say Jaeyoon, I'll leave the Jaeyoon, and then secret.txt. In that case, it says operation not permitted. If it is not permitted, because why? This ownership is right now Jaeyoon, but somehow I do not have any ownership myself from Jaeyoon. How can I change something for Alice? Alice another entities. Somehow different privacies, right? So it is not allowed. But if we use sudo, we could do that. Therefore, when you do ls-l secret, then it can now, owner is Alice and the group is Jaeyoon. Very nicely that we changed it, right? The key point here is this discretionary access control, although it is not permitted, here operation not permitted, even if it is not permitted, if we use root privileges, sudo, this command itself works. Discretionary access control enabled, although there is some the security barriers, it could be enabled if we borrow root privileges. To make the system more tightly, securely, then even if there's a root privileges, the security policy is a policy. So policy should be enforced strictly. No exception. How can you make it? That is mandatory access control. That is a case that mandatory access. And remember the next slide? This is a mandatory access control. This from the system, not the user discretionaries. So it could be works if ch own due to some of the reasons not permitted, but if we borrow root, see here, I made some comments here. If a process runs as a root, it can usually bypass, no, not DAC, bypass MAC, right? bypass Mac, DAC. I think this is DAC. Bypass some other, you're right. Another thing here is set file access control language. We call that set FACL. That is also possible. You cannot practice because you do not have Alice accounts, right? So today we'll look at we can create more and more users. You can practice it. But since I have that, I can handle it. But we can practice it later. Now we can do, let's say, Morsi. Morsi is another user. So this last ones that we can practice very quick. There is a command called the set file, F for file, ACL for access control language. I want to make it M, and user is, let's say, Morsi. User Morsi, I want to give see, Morsi is what? If you see this secret, Morsi is not the owner. So owner is Alice. Morsi is not in the group Jaeyoon. So Morsi is others here. If Morsi is other, then Morsi cannot do anything, right? But I can make it possible. For example, I will give read permission to Morsi on that specific objects, which is a secret.txt files. This is not permitted, of course, because there is a issue, right? But it can be avoided if we use root. So sudo, then it works. So after that, ls-l secret. Still, as you see here, rw here plus some of the signs here, right? So I give Morsi, user Morsi, to read the permission on this specific files. That is also possible by having this set FACL, but this command itself is not permitted according to this DAC, discretionary access control, but it can be avoided by root privileges, sudo. So discretionary access control is very, very handy because it is, as a user, you can handle it very, very efficiently. Although we do not have any, the system itself. The next one is the system itself. So we don't, many cases, we cannot, right? Because the system itself, this is more mandatory access points. So we may be able to see, oh, do we have access controls? This Mac ones. You can see that by because this is our case, Debian distributions, which is part of Raspberry Pi OS. So it has AppArmor installed. So it can be checked by this A from app and another A from Armor. We can see the profile status of that AppArmor availability on our system. So you can do AA-status. Then you may be able to see here. AppArmor module is loaded, but it is not mounted. AppArmor file system is not mounted. So we don't do. This file system is not for that AppArmor. that requires lots of work, so we don't do that. But actually, I want you to see today's lecture. There is two kinds of access control: discretionary and mandatory. Mandatory, if you are working on Raspberry Pi, then because it is a Debian distribution, part of a Debian distribution, Debian distribution has loaded AppArmor. In order to make it, then you have to make your file system AppArmor styles, but ours is not. We do not mess up our file systems. Okay, so that much I want you to understand. But discretionary access controls, that we will do more. Okay, so to that, some of the command that we need to understand. ID displays user identity that we looked at, right? So right now, if you see who am I, then I said, oh, there's a Jae-yoon. So let's see your ID. Then it gives me some privileges associated with me. And then change mode that we practiced here, right? Change file mode. UMask, we already looked at. That's a set the default file permission. Our UMask is 0022. What is SU? We want to see the manual of SU. SU, run command with substitute user. So SU stands for substitute user. Okay. Sudo, that is for super user privileges. CHOWN, we already looked at, right? There's a file ownership. If you see the history, then we had change ownership, and we had change mode. Similarly, we can do change group. The way that we change group here, oh, we didn't say it, right. Password, that is, password itself is a command. Okay, so right now, my password, Jae-yoon. If you want to change your password, you can change it, right? So I think my password is Mercy itself, but let's say password and Jae-yoon, then we can change it. So what is the current change password for you? Current password, Mercy. So new password, I put Mercy again. And one more. Then it can be changed. Password cannot be changed because this is the same, right? Same ones. Change. Should I change it? No. So I can kill this process. How can you kill? How can you interrupt this process? This is nothing but a process, one of the process, right? Process that you can see here, PS, AWS, and then you can do grep, Jae-yoon. Then you may be able to see here, there's a password. This is one of the process. So if you want to kill this process, then I think this is a process ID, 2750. So what you need to do is you can kill that, for example, kill that process, completely, then there is option 9, and then you can say 2750, then it can be killed. Therefore, it is killed, right? It says killed. So that process, anything that I want to make an action, then that is called a process. Process can be listed by this command. And this command gives me a list of a process, whole list of a process. Process, for example, like this, then let's see. Main APS. So what? AWX is better, right? So we can do PS AWX. Yeah, it is a long list, right? Long list of those. There's a process. There's a change it. These are the commands that we can use. Okay, user group. So on Linux, we have the user account and then group account. Well, actually, it is not the account itself. It is, therefore I said it's not a file, but some of the grouping, some of the ID. So user is that the primitive level of IDs that represents someone capable of using files associated both with the human and process. So that is user. Another one is a group. Is a list of user accounts. Users have a main group and may belong to other groups as well. So not only one, but more than one. Okay, not finally. This is very exciting moments. So we want to create a user. There are two commands possible, using add user or user add. Originally, long time ago, there's only user add command available. But these days, this is a little bit handy, add user. This is more user interactive mode. This user add is command line. So look at this. Either one of these, you can create a user. You can do sudo add user and username, or sudo user add, and then you can use some of the options. Option that most likely useful when you create a user add, you can use -m. There's a home directory. And the -s shell. So if you want to make a home directory, then you need to make -m. If you want to set a specific shell, then you need to say -s and then give shells /bin/bash. Someone may ask, what kind of shells do you have? Then you need to do, I think, cat etc shells. Then you can see the list of shells. cat/etc/shells. It gives you the list of shells. Those are the shells available in your systems. Me, myself, what kind of shell is given? It says How can I see the shells? You can see the shells. Simply cat etc password and then grab Jaeyoon, then you can see your shell. Shell that is given to me is //bin/bash. So one of the shell is given to me. This is by default. And then username. You can do more. This home directory and the full name. If you want to add a user group, then you need to sudo user group, user mode. -a means you want to add, G means group, and then there is a sudoers group. If you want to add Alice into the sudoers group, then you need to do this. And then groups Alice, then you may be able to see what it is. So for example, groups is another command, right? So if you want to see the groups, then it prints groups a user in. Therefore, groups Jaeyoon, then what kind of groups I can be in? I am in myself, Jaeyoon, and admin. Okay, because I can see who is, no, the other way. Who am I involved in? CD-ROM sudo, this is important ones, audio, video, plug device, games, users, input, render, SPI. This is for, because this is the Raspberry Pi, we have a serial port interface or interface to communications, GPIO, and many others, right? And there is another group called Cyber. Let's see if there is a group Cyber that we looked at already, right? So we can see cat etc groups, then group, then you can see the groups. Jaeyoon's group is 1000. I created probably Cyber groups. Cyber group here 1004, where there is a Jaeyoon and this, right? Two guys can be in that Cyber groups. You can make that. So let's try to make a user. First, as sudo add the user, and you can make whatever that you want to. Okay, name of another. Your first name, your last name, your sister's brother's name, your whoever, your parents' name. So add the user, and then I put Adam. Then it asks, adding user Adam, adding new group Adam. So 1011, by default 1011, group is 1011. Create home directory is /home/Adam. And then copy files to etc whatever. And then it asks me to enter a new password. So I put there Adam also. Otherwise I forget, right? So Adam, and the room number, you can hit enter, no, nothing, and information correct, yes, and it is correct, it is. Adding a new user, Adam, to supplemental /extra groups users. So after that, when I go back, right now this is myself, right? PWD, I am under home. This guy Adam also under home. That is Adam's home directory, right? So I want to see if there is a Adam. How can you see whether the Adam is available in the home directory by having one command, single command? Then you need to do ID. How can you can do ls dot from here, then you can see Adam. This Adam's directory. Because you are now /home/jyun, and you assume Adam, the user account Adam, is also under /home directory. If you want to see it, then you need to do list what? Instead of a file name, you can say ... which means I want to see my parents' content so that I can see Adams. If you want to see a long list of Adam, then ls-l space . Then you can see. When you go Adam, what is Adam here? Adam is a directory, right? That directory is now, if you see this permission bits, first bit it says T. Previously, when you see others, then for example here, ls-l, then first bit is dash, right? Because this is a file. If it is a directory, these are all the directories, right? Directory, then it says D for directory. And then the permission bits, same as the file case, right? So Adam itself can read, write, and execute. And all others cannot do. Same thing, Alice can do read, write, and execute into herself, but no one can do, not even the same group, as well as all the world. So for example, if I want to do Sue Adam, substitute user Adam, password of Adam is Adam, I just created. So I can go into Adam. How can I see? PWD is here Adam, right? So if I do SD and tilde, which is my home, where is it? Adam, right? PWD is Adam. So when I come back, Adam, because I am Adam, ID is Adam and Adam, I can get in here, right? But if I want to do, for example, go up so that I can see all others, I want to change it to direct, let's see, ls-l, Jaeyun, I allowed that. For example, Alice. I want to change it to Alice. So change directory to Alice. Permission denied, right? Because Alice says only Alice myself can read, write, and execute. No one in the same group, all others, only slash, right? But Jaeyun here, it allows, right? So Jaeyun allows anyone can do execute, which means we can change it, right? Change Jaeyun. So I can get into Jaeyun. That's what it is. And all others can read also. Jaeyun. So I can do here all others, right? Those are indicating, the permissions are indicating here. Looking at the folder, the user, you may be able to see which one that I can get in more, right? Okay, that's what we had here, add user. So you can create more user. So now when I come back here, cat etc.password, then I may be able to see here Adam. Adam I just created, right? So how do you know when Adam is, how long ago Adam was created? We can see that from cat etc shadow. It is permission denied so that we can do sudo, then we can see it. The last item here, Adam. And then next item, there's a password but encrypted all the way up to before that another colon. Colon is delimiter. Adam, colon. The first one is username and the second one is password, but that is encrypted. If you see that encryption algorithms, you can decrypt it. Therefore, you can get the privileges of that. And the next one is 20,528. So I'll explain that 20,528, what that means. And the next one is 0. Probably it says how many the denied, how many days that, for example, how many days that you can you can change your password. How many longest days that you don't need to change your password, which is 99,999, and how many days, although you change, you enforce that person to change, how many that you allow him to take the time to change, maybe 7 days and more and more. But this number, 2,528, what that number is. If you see that similar numbers find, for example, Jaeyun, then it says all the way to here, there's a 20,341. Do you see here 20,341? This is 20,528. This is a bigger number. This is a smaller number. Are you curious? You don't need to know. You're not interested in what that number is. No curiosity. Anyone can guess what that number could be? Anyone here? Huh? Oh, number of dates. Oh, Nick, you know anybody who work on computer should know. There's two kinds of time. Our calendar time is what? What is a mean time? What is a standard time of our current time? That is called Greenwich Mean Time, right? It is called the GMT time. So what is the standard times? The Greenwich in England, that is the standard time. From there, how many days delayed, how many days ahead, we count that way, right? That's a standard time. GMT time, we call that GMT. So GMT time created far earlier than the first computer can think of. The Linux, when was the Linux first invented? We talked about that at the first time of this semester. It was invented by whom? The Unix. Linux was invented by a student groups, early 1990, right? I still remember when I was a student, 1990. Then, oh yeah, we are. So Linux was, before Linux, we should use Unix. Unix is only the reliable operating systems. At that time, we already had Windows and Macintosh, but those are like a toy. So real computer was Unix. Unix was invented by Bell Laboratory, Bell Lab, so-called Bell Lab. Bell Lab was a leading company in 1970, 80, something like that. It was like Tesla, Meta, Google, something like that at that time, right? So Bell Lab invented the Unix operating systems. Around the time 1969, and I think it was the first version of the Unix completed in 1971. So there is a year in between, which is 1970. So they decided, okay, our standard time starts from January 1st, 1970. January 1st, 1970. From that time, they count one day after, which is January 2nd, 1970. And then January 2nd, 1971, then that is 367, maybe, something like that, right? So every time, whoever counts dates, if we count it from that standard time, then we know which one created earlier, which one created later. So everything counted from that times. Okay? So I will show you, this is a little bit extra if you are interested. And you guys know already Python, right? So I can bring up Python here. And Python 3. So I have a Python 3. I can do from date time. I want to import date and time delta. So I have date. So I can count from 1970 1.1. So from that time, I want to give time delta, how many days that we are thinking of. So how many days? It says 20, 528 days. Then that is 2026, March 16. That is the date of today's, right? So it was counted from 1970, January 1st, counted from this date. How many days passed from that time? 20,000 days passed. So that is the two dates. Then you can think of when Jaehyun was first created. Jaehyun created. It is not just created, it's modified. So when the Jaehyun was modified, it's 341. 341. Then we can see 2025, September 10th. So last year, yeah. Last semester that I created this. It is called the UTC time. UTC. UTC stands for, I think, Universal Time Coordinated. Some of the coordination is needed among computer systems so that we can see which ones is earlier, which ones are later. So there is always, they need to count from that standard time, which is 1970, January 1st. We call that UTC time. It's not GM. It's not GMT, which is Greenwich Mean Time. I think this means Universal Time Coordinated. If it's GMT, then it's called Greenwich Mean Time. Okay. This is for extra. Then you may think of each computer has allocated some memory. It's not really memory. Some of the ROM, not the RAM, ROM, they carve some of the dates there. The size of the memory there is 4 bytes long, which is 32 bits, right? So using 32 bits, there is because we are allocating only that 4 byte long size of a memory that can count UTC time. There is sometime it can be full. That 32-bit long memory may be full. Right now it is each day it adds one more and one more bits. It uses one more bits and one more bits. Each bit can be zeros and ones, right? So they can count, for example, if we have 2 bits, you already know that, right? If we have 2 bits long, then first time it'll be 0, 0. Next time we add one more, then 0, 1. And next time 10, and next time 11. If we have only 2 bits, then only we can represent it 4 kinds, right? So 32 bits. So also there is a limit. Do you know when it'll be limited? When it'll be full. So no more that we can count UTC times every single systems, operating systems. There is a 2039. It'll come quickly. So while you are, after you graduate, maybe within 10 years, you will see there is another big issue. The computer operating system's time is full. There's no more that they can add. You guys may not remember that. There is a the new millennium around 1999. Everyone born after your date of birth starts from 2000, or anybody has a 1000 like me, 1090? Anybody has a 1099 some? You are? Oh, so you still you cannot remember, right? There is some of the expected crisis when the new millennium comes, which is the December 31st to 1999. Everybody's think, oh, the world will continue, or that is the end. When it comes to December 31st to 1999, nothing happens, by the way. But maybe 5 years prior to that time, the computer world, all the computers, they need to cope with any potential crisis. So what they first changed was the year. Before that time, when you make any dates, we said 2 digits of a month, or 2 digits of a date, and 2 digits of year. Okay, for example, 1995 December 12. Then they said 12 12/95. That is enough. But when it comes to 2000, then what happens? We have 00. 2000 means if we take only last 2 digits of a year, then that'll be 00, right? But there is another one, 1900. Somebody is born in 1900. Somebody is born in 2000s. Both using only 2 digits of a year, then there is a 00. They could have the same the birth dates, but the difference between those two guys are 100 years, right? Newborn babies also /00, because there is a 2000 year born. And there's older ones who was born in 1900, also counted last 2 digits, 00. So because of that, what happens is that they need to update all the year number should be in 4 digits rather than 2 digits. So whether it is a 1995 or 2095, that was so all over the world, all the computer needs to update. So up to that point, up to maybe 1995, 96, up to that point, they simply use, we enjoyed of having used only 2 digits of a year. So 80, then that is 1980, of course. 85, that is 1985. We never think of 2095 or 2085. Similarly, this UTC, we may have that kind of expected crisis, but not that much because we already had that experience when it comes to new millenniums. But anyway, that is another extra point, extra things that I say. Okay. So we create the user and we see because of that the permission, access control, who can get in, who cannot get in, right? So we looked at that. And as a Adam, who am I? I'm Adam, right? Adam is not in that sudo. For example, groups. I looked at here. Cat etc groups group so lots of groups, right? So I can do right now sudo group ID is 27. Right now Jeyun is only the sudo. So you can see, I want you to issue this command so that you can see on your computer who is in that sudo. I know Nick, Julie, Chris, who else now running Raspberry Pi OS? Windsor, are you running Raspberry Pi OS right now? What about color? You didn't have it? So I wanted to check that if your name is in that sudo. Huh? Yeah, you have, right? Oh, you put Alice already? So now we want to practice this. Sudo user mode. Let's practice. Sudo user mode. So what is user mode? I want to check here. Man user mode. Then modify user accounts. This is a very, very powerful command. Okay? Append, bad name, C. We have two options, -a and G. So we want to append. We want to use this. And then there is a minus uppercase G. Small one is group. Bigger one also groups. List of supplementary groups, so we're going to use this. So what we will do here, sudo user mode -a and uppercase G, and I want to put that in sudo. Who I want to put? I want to put Alice. Permission to sudo, right? So what is my mercy, right? Am I not mercy? Oh, it's password for Adam. So Adam password is Adam. It says Adam is not in sudo's file. So Adam cannot do this. Okay? Only who can do? Because sudo is only allowed to Jeyun. So right now here, who am I? Jeyun. So this this command sudo user mode ag sudo alice is available by this jyun. So I want to redo, because here Adam cannot do this because Adam is not in the sudoers file. So we'll do sudo user mode ag sudo alice. Oh, this is very quickly, so that I can do cat group sudo. Then I see here previously only jyun, because I add Alice into sudo's list so that Alice can do, right? Once this is Alice, then for example, su substitute user Alice, probably Alice again. So right now is Alice, right? Alice can do sudo user mode -ang sudo, and I want to put Alice, Adam. Adam was not in the list, but Alice first in the list. Now Alice wants to add Adam because Alice now have that privileges, sudo's privileges. So Alice can include Adam in the sudo's list. So it says Alice password Alice. Therefore, Adam also in that Alice list, sudo's list. So I can do cat etc group grep sudo. Now one more, right? Adam is also in the sudo list. Sudo is a very, very powerful the privileges. So you have to add sudo's privileges, sudo's list very carefully, very, very carefully. And therefore you have to know how to exclude. So man sudo man user mode. I want to see how can we exclude. Probably -x. Let's see, -o, -p. Oh, remove. I think remove. Let me do one more. I saw -r. Remove user from the named group. Use only with the -g options. Okay, so what we need to do right now. So I want to exit from Adam to Jyun. So I'm now Jyun, and still I can see cat. Then sudo's in that list, Jyun, Alice, and Adam. Because Jyun is, although Adam is added into that sudo's by Alice, Jyun can remove him. So I can do sudo user mode -r and g sudo Adam. I want to remove Adam. And I want to see cat. So now Adam removed, right? Now only that. So that privilege was revoked. This type of things is very, very important. And as a system administrator, you have to know and make a careful decision whether you want to grant. Once it is granted, you have to monitor the activities of that person's privileges, and at another points in time, you may be able to revoke the privileges that you once granted. That's what we looked at here. Okay. Any question, any comments on this? This is very, very important. So let's move. This is some of the password management. For example, password lock. If you want to lock some of the password, that's possible. Sudo password -l Alice, then you can lock it. Also, you can unlock. Show password aging information. So, for example, sudo change -l Alice. Oh, change is not possible. Oh, this is not possible. If you want to change, for example, expires the password, then you can use this, but it's not possible, right? And user can be deleted. So you can use sudo. If you want to delete Alice, then del user. Add the user or del user. So add the user, then you can add del user, then that is delete user. Groups that we looked at. We already looked at this, right? So there's a password along the group. Yeah, we looked at that. If you see the password, then you can see this, right? Where is it stored? It is stored in shadow, right? We looked at already, right? So it is, before we look at etc shadow, then this shadow is owned by root and group shadow. Root can read and write but not execute. And the group can read and all others cannot. So we cannot use this. We cannot read this. If we want to read it, Jaehyun, for example, if you want to read it, then you need to get the root privileges by having sudo. And then you can do cat. Then you can see that password information, right? As you see here, this is Adam's encoded password. This all we already looked at, right? etc shadow contains sensitive fields. Password hash, last password change date. So when was the change? It was 2,528 days after, since January 1st, 1970. It was counted from that. So it was modified today. Today is nothing but that much number. It elapsed since 1970. And minimum and maximum days between changes is 0 days and 99,000 days. Warnings and inactive and expiration fields. Those are coming. It stores password hashes and password aging information for local user accounts. Is readable only by root. but you can read it by sudos. So we do add user and some other options that you can use. For example, add user, you can change the shell. Right now, let's say Adam. So tail etc password, then Adam's shell is bash, right? So if you want to change it, that add user's shell to bin, what kind of shells that we have. So you have to understand the shells. So you can get cat etc shells. We have /bin bash that was there. If you can change that to /bin rbash, then here rbash to Adam, for example. Oh, this is a new user. So, for example, rather than Adam, maybe Eve. Okay, so password is Eve. And full name, Eve Adam. And yes. And after that, if you want to see tail password, then remember that Adam's shell was /bin /bash, but Eve's shell is /bin /rbash. Okay, this is a little different versions of shells. So that's what you can do. You can add by having the home or some create home. And then if you want to set expiration, you can do -e. For example, I want to do sudo user add -e 2026 December 31st to Eve. Password for Adam. Oh, right now Adam. Adam cannot do this, right? Because Adam was excluded from that sudos list. Therefore, Adam is not in the sudos. So if I do exit and then sudo user add -e 2026 12. Let's try to do 3/31st. Eve. Already there. So I think we need to change that. Rather than this goes with the user creation. So because it says user add, right? If you want to change a password, then you can do password. Password is a command. If you want to delete, then delete user. Group, you can do also add group using the add group or user mode -ag that we already looked at. Password, delete group. User inspection and monitoring. You can do, for example, here W, then you can see those who are in your system. Right now, only Jae-yoon. who's logged in, last recently logged in history. So last, then you can see reboots Friday, March 15. Get ENT password, all accounts recognized by the systems. Yeah, some of the user activities that you can see from var/log auth.log. All the systems has that ones. For example, if you want to see ls-l var log auth.log, but it's not in. Oh, it's still there. Okay. If it is there, then you can see that sudo tail -n. You want to see the last 20 lines of that file, var log auth.log. So, for example, here, 2016 March 6, 2026 March 16, which is today. Raspberry Pi sudo the session opened for user root. Let's see what others here. This is activities that I use this command, right? So this guy also logged what kind of command that I did. Let's see what else here. Some of the failure that I made here. User add. Remember that I tried to do add and I skipped that. There's a failure. Another command that I didn't do. I stopped here. I tried to add expiration dates to if. So that those very, very useful informations already logged here, right? So how good it is. So for example, if you want to do this more, then you can see more and more. Each window, each page, only 4%. For example, 2015, last night, they're all similar. Is there anything that I can see? There's some of the cron. We'll look at that cron. Cron is a very, very useful one. What cron can do is that if you want to set some of the executions, for example, hey, every 2 o'clock in the morning, do this. Then every day, 2 o'clock in the morning, it can do that. Some of the actions can be scheduled chronologically. That's called the cron tab that you can see here. And then more actions here. Let me see, 2016 here. I made a group add, right? Some of the things already here, Adams. Those things are already logged here. So user activities can be monitored and inspected. There's as I said here, modern Debian runs systems or either logged this on this auth.log or there is a Another thing that you could do using journal control. So show logs for SSH services. If we had the SSH services, right? For example, sudo journalctl -u SSH. Those are the SSH already. For example, this accepted the password for JUN that change the default to shell and home directories, that we did that, right? User mode. Okay, file system security. File, everything is a file, and the I/O device is a special file. For example, /dev cd-rom, then you can see the files. ls-l dev, that is for device. Where there is a cd-rom, then you can see, rather than having that dev, so many devices. So instead of cd-rom, you may be able to see some others. GPIO. More about the Raspberry things. CD-ROMs that you have to activate it. But right now it is not there, right? So we'll look at that later. File mode and permission strings, ls-l. We already looked at this, right? So file mode. Here, first three ones for the user, and then next three for the group, and next three for others. So this is for other, group, and owner. So we looked at this, the three identities, owner, group, and world. Three privileges, read, write, and execute. Among those, then we can calculate that. CD mode, that we use this kind of numbers. 7 means everything, right? 5, 5. 5 means 4 plus 1. Then 4 means read, 1 means execute. So ls-l, right now that is that. You can change, for example, ch mode 755 secret.txt. Oh, it's now Alice. It's owned by Alice. That is the reason, right? I am outside. So I can do touch another file.txt, and I can do what is the mode. File.txt is read write slash read slash slash read dash dash and read dash dash. So I can change it, the mode 755. Guess what it is? 7 means RWX. 5 means RX, RNX, right? So if I want to see, then RWX, and the next one is RNX. R and X. X means then there is executable. Although file.txt is not executable, but we can do that. So this is, you can make this octal permission with the number. Actually, 4 numbers that we put there, right? But as I said, the fourth number, we do not usually use. Only last 3 digits uses. That is for the permission only, right? The fourth number, that's for special. So we'll look at that. You can use this number. Using number, you can set the permission. Or simply you can use RWX and then WGO. Okay. So rather than having 755 here, you can do, for example, if you want to put here, you want to remove this X for all the users, then you can do chmod and then all others. I want to extract, which is minus X for the particular file.txt, ls minus L. Then previously I have this. So all others, I have Rx. Right now, R dash dash. So no X because I said minus X. Okay. You can do chmod group. I want to add write privileges. Right now, group does not have write privileges, right? Read and execute only. So I want to give write privileges to that file. Then I can see RWX and RWX instead of R-X. So we can use a symbol or number. They make the same effect of the privilege. Ownership, we can change it also. We looked at that also. Revisit that. Okay. So the problem, remember that if we have a root privileges, then we can do everything, right? Which is handy. But the problem here is every time then user may get the root privileges by having the sudos, right? So you do not want to, because root privilege is very, very powerful. So is there any way that we can do, for example, only that's here the solution, make carefully written program as a set UID root, so it runs with the root effective UID only for that programs. Only when you do execute, you do not want to make it available as far as there is the sudo. Of course, it is possible, but you want to strictly say, hey, this is for somebody can do. More explicitly, is there anything that you could do? Yes, we can do that. That is for the using 4th digits. Remember that we use 775 in the previous slides. If we add in front number 2 means set group ID. Number 4 means set UID. Number 1 means sticky. Those 3 things are very, very it's not really powerful, but very, very, this for security reasons, that is a very good tool. We do not need to abuse root privileges, but we can pinpoint to assign, to grant some of the execution privileges to someone, right? So if we say 2775, then this 775 is for the owner, group, and the world file privileges. And the fourth digit, which is leftmost digit, that is number 2, then that is for the set GID. Number 2 means set GID. Number 4 means set UID. Number 1, state key. So what does that mean? If it's a set UID, when an executable file has a set UID set, it runs with the effective UID of the file's owner. I want to show that. ls-l etc password, then you see that is this password privileges bits is rw dash r dash dash r dash dash. I want to show here, I want to show the same thing here. ls-l USR being password. Do you see here? They are very similar file names, password and password. But the password file in /etc, that is simply text file. The password file in /usr/bin, that is an executable file, so that you can see here the red mark. And if you see the privilege bit /etc password privilege bit is simple, right? Read write something, right? But this password here, that is nothing but the command password. If it is in /usr/bin /password, then that is executable. So bit files here, privilege bits is rw, and it says what? S. Rather than rwx, it says rws. What does that mean? It means user set user ID. User ID is set for execution. To run this password, I don't need to do sudo password. Password is a command, right? Password is a command. But password is a very, very important command. You may want to protect it from any arbitrary execution, right? Then you need to you may try to avoid that. But in this case, there is S. S means if you are a user, then you may be able to access it without having to sudo. So that I simply say sudo, and I'm the owner of my own record here, Jaeyun. Then I can change that, right? It allows. Why it is possible? Because I have here S. Of course, I want to interrupt it. Control C. If Control C is not working, then you can do here PS minus AUX, and then grep Jaeyun. Then there is this one is the process, right? See here, process password Jaeyun. At that time, it is the privilege itself is a root. It is possible that I can get the root privileges because I have here S. I want to kill it, 3289, so that I can do kill minus 9, 3289, so that is gone. So it is killed, right? Although, where is that previously? But anyway, so in that case, I can use it, right? Similarly, group ID, if you want to put their number 2, then run as a file group or enforce group inheritance in a directory, so that as you can see here, RW instead of RWX, you may have RWS as for the special group permissions. Bit sticky. So set UID, that is for number 4. So it'll be 4 X. This is set, the GID is 2 X. And then sticky bit, there's a 1. Only the owner can delete their files in a shared directories. That's what it is. I do not want anybody to remove only but the user, I mean the owner. In that case, you need to use sticky bits. If it is a sticky bit, then you can see T sign. Okay, so you can change the mode plus T to specific files. So I have here -L. I want to touch another file, another.txt, ls-l, then another. By default to this privileges, but I want to do sudo chmod and plus T sticky bits into that another.txt, ls-l, then you can see the T. Okay, it means only the user can delete this. If you want to do -T, then that sticky bits can be removed. Okay, I think this is the last slide. UMask affect default permission for new files and directories. So new file starts from 666, and then UMask bits are removed. Don't get X by that. if it is a directory 777. So I want you to have, for example, example 1 and example 2. This is a little, so let's practice in this way. We already did actually this, right? UMask 222 for the file case. That is the one here. When you touch this another.txt, then by default, here, this is first time, right? Because UMask is 0022, when you create the file, then 022 is subtract from 666. So it'll be 644. So now I want to make a directory. So mkdir, and then we can say subdirectory, right? So ls-l, then we have here, there's a directory d, rwx, r-x, r-x. So how come we have rwx, r-, that kind of things here? That is 022. As I said, if it is a directory, then it can be subtracted from 777. Then our mode will be 755. 7 means I want to grant everything, read, write, and execute. So I grant read, write, and execute to order, right? To owner. Number 5 comes from read is number 4. Execute is number 5. So I have read x, read-x, read-x, right? That is for the directory privileges. So by default, I have these directories. So actually, the file permission is a 666 and minus UMask. This is a 777 and minus UMask. That's what it is here. Okay, this is for the directory. And if it is a file, then we'll look at the file somewhere here. This is for the file, right? For the files, we can do like this. Okay. 2 things. I think this is it for today's lecture. You guys are somehow, are you guys tired?
Midterm is next week, right?
Huh? Next week is a midterm review, and the week after next. So which is, I think, 30 and 31st. If you come here in Manhattan, then March 30th. If you come to Dobbs Ferry, then that'll be March 31st. So Monday or Tuesday. Monday here in Manhattan and Tuesday at Dobbs Ferry. Manhattan exam begins 9 o'clock. Dobbs Ferry exam begins 10:30 in the morning. So Monday or Tuesday. And you will have the last homework assignments before your midterm about today's lecture so that you can practice some of this at home and submit it. Question? Okay. Then I will see you in person in 2 weeks, maybe virtually next week over Zoom. Okay? Next week, yeah, over Zoom. Didn't you receive? You guys already received. Yeah. Either announcements or I think probably an announcement, right? Okay. See you later.